So, hello. In this video, I would like to highlight and explain the different paradigms of the machine learning techniques. Uh, as we know, like we have different aspects that can be considered when we're talking about machine learning, introducing different paradigms there, starting from what's called the supervised learning, the unsupervised learning, the semi-supervised concept, and the reinforcement learning. So the goal of this um, part of the presentation is really to introduce these different paradigms there and then explain each one, hopefully in a way that we can grab the basics of what we mean there for each paradigm in the machine learning process. Now, if we start with the supervised learning, the machine learning uh, uh, algorithms or the machine learning concepts here, we're always expecting, as said from before, now the gold mine that we have is the data. And in this paradigm, basically what we're having is that we're given the data sets that has the input and the desired output. The inputs can be given as the independent variables x, and the desired outputs will be given as the dependent variable y. Now, the objective here is really to develop an association model that can relate the inputs to the output and then can predict the output for future inputs. Okay, so if we take a simple formula of how to represent this, then we can say that the xi is given as the inputs. We have the independent variables or the attributes or the inputs, the features that we have. And the function of these x is equal to the output, the y. And here we try to look at different features. So this xi could be starting from one feature to multiple features to n. Yeah. So n will be the number of the independent variables that we have in the data sample itself. And in the supervised learning, as you can see in the figure that I showed here, is that the output will be belonging to a set of finite or discrete values that can define the predicted classes, whereas in the regression function, we have the output belongs to a range of infinite continuous values that define the numerical outcome. The model will utilize the training set in order to compute the best fit. So if we look at the figure here in the bottom right part, so we have the inputs that are given in these bars that you can see in gray, and the output is the orange one. When here we're trying to learn the model, like to see the trends between the input and inputs and the output. And then we design the supervised learning algorithm that we need. And then from there, we extract the model that represent these inputs with the outputs. The goal is that whenever we have a new sample where we have different features, different inputs or independent variables, then we'd like to expect this output that we don't have from the model that was already trained from historical data or from data that we learned its output from before. Okay, so this is basically the supervised learning. It's basically like if you have a learner or teacher who's teaching you the steps, and then like as a small kid, they're told the steps of how to walk and so on, and then we're hoping that this kid now tries to do it by itself. Yeah, so this is basically what we try to do in the supervised learning. The applications where supervised learning can be implemented can be like if you have prices of the houses. Let's say that you have a house in a specific area, and this house like is affected by the number of bedrooms there, the location of the home, is it a home apartment, and so on. And then the prediction of the prices, like if you have the history of the prices, like last year, the year before, and so on. And then you'd like to expect how much this house worth in the future, like next year. Yeah. So we learn from the trend that we have from the previous years, and then we can try to predict it in the next year. Or if you have multiple houses in the area, like you study the multiple houses prices according to its location, to its size, to its the number of bedrooms, and then you would like to predict a new house in the in the area, or with some of these parameters or some of these features predicted according to the history that you have from the area or different areas that were there. So this is an example where the supervised learning is employed actually, and the prediction would be like how much is really specific homework, and this type of task will be a regression task, as explained in other videos. Now, the previous loan that we prepared, again, we would like to know here to answer the question, will this client default for a loan, yes or no? Then this is a classification task, yeah? Previous week visa application, how many business persons will apply for the visa next week, for example? This would like also to predict some value, and this is a regression task. Previous statistics of benign or malignant cancer. Is this cancer cell, like to answer the question, is it malignant or benign? Then again, we have a classification task. Now, next is the second paradigm, which is the unsupervised learning. It's basically like if you have a person that you're hiding your eyes and you have this basket of fruit, and this person who doesn't see now the basket would like really to, according to some similarity between the objects, to try to pick a random object and select to predict or know what kind of fruit is this according to physical characteristics of the fruit that you pick, maybe